In this video, I will teach you how to perform reflections. Before we get started, I need to introduce you to the 4 reflection rules that I really want you to memorize. If you're reflecting over the x-axis, a normal point x comma y will become the point x opposite of y. And I encourage you to read that negative sign as opposite. So the x stays the same, the y becomes the opposite of y. If you are reflecting over the y-axis, the point becomes opposite of x and then y. If you are reflecting over the line y equals x, the point becomes yx. In other words, it just switches, the x and y switch places. And if you reflect over the line y equals negative x, the point becomes opposite of y, opposite of x. So they switch places and they change signs. Now, some of you may not know what the line y equals x is. So let me just illustrate that for you real quick. So let's say that if this is the y-axis and this is the x-axis, the line y equals x would look like this. I think I'll do blue. Alright, the line y equals x is a diagonal line right down the middle. So this is the line y equals x. Similarly, the line y equals negative x is going to be like this. Again, so if this is the y-axis and this is the x-axis, the line y equals negative x will also be a diagonal line, but this will be a diagonal line going down from left to right, like this. So this will be the line y equals negative x. Alright, so keep this in mind as you're doing this lesson and watching this video. Okay, let's get started. For the first problem, we are told to reflect over the y-axis. So that makes me want to jump over to the rule, and we just learned that if we want to reflect over the y-axis, it's going to be the opposite of x comma y. And again, I'm really just copying that right off of here. Okay. Now, I can use the rule to come up with a prime, b prime, and c prime very easily. So I'm doing the opposite of x, y stays the same. So the opposite of x is 2, y stays the same. The opposite of 0 is 0, y stays the same. The opposite of negative 5 is positive 5. The y value stays the same. So I could plot these points right now, boom, 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 and I'd be done. But I want to point out the common sense aspect of this as well. If I want to reflect across the y-axis, it's probably quicker just to look at the graph. Point A is 2 units to the left of the y-axis, so A prime will be 2 units to the right. Now that does match what we came up with algebraically. The 2 comma 4, you'll notice this is the point 2 comma 4. Now notice that the point B is on the y-axis, so the reflection will not move, alright, because it's on the reflection line. So I'll just write b prime next to this. But the point C is 1, 2, 3, 4, 5 units to the left. So I'm going to go 1, 2, 3, 4, 5 units to the right, and that should be C prime. And now we can just draw that shape. So that's it for problem number 1. Moving on to problem number 2. This time we are not given the description. We have to find that for ourselves. We're given the picture. So first we have to decide, is this a reflection over the x-axis, y-axis, y equals x or y equals negative x. So looking at these pictures, this seems to be a diagonal reflection. And the mirror line seems to be right about here. This is the mirror. So, of course, this is the line y equals negative x. So, what we have is a reflection over the line y equals negative x. And we decided right from the beginning that the rule would be opposite of y, opposite of x. So that's what we write. Opposite of y, opposite of x. So that makes it really easy. Okay, actually I should have written this over here. We are reflecting across y equals negative x. Great. Now, this part is easy. So opposite of y, in this case, y is 4, so the opposite of y is negative 4. X is 2, so the opposite of x is negative 2. The opposite of y is negative 2. The opposite of x is negative 5. Hold on, I got a stray line in here by mistake. The opposite of y is positive 1. The opposite of x is negative 2. So that's it. We're done with problem number 2. So moving on to problem number 3. Okay, so they gave us the rule this time, and we have to do everything else after that. So see how it says yx. Well, let's look back at our notes. That is the rule for reflection over the line y equals x. Okay, so this is reflection across y equals x. And y equals x is this diagonal line that I'm about to draw that goes like this. So this is the mirror line. So when we are all done, this triangle should be over here somewhere. But let's use the rule on these points. I think that would be the quickest thing to do. So this says just reverse the x and the y. So this will become 1, 5, negative 2, 1, and negative 4, 4. So 1, 5. Negative 2, 1. Negative 4, 4. And that's it. So this is A prime, and this is B prime, and this is C prime. So that'll do it for problem number 3. Now it's time for problem number 4, and I think this is the trickiest type of problem. We are not given the description, we don't have a picture, we don't have the rule. Instead, they just gave us the set of points. We have the original points, and then we have the points after the reflection is done. So we have to figure out what the rule was ourselves. Okay, so let's just look at it and see what happened. So let's make up a point and call it x, y. All right, a generic point x, y. So let's see what happened. So x is negative 3. What happened to that? So let me use colors to make sure it's really clear. So I see the negative 3 right there, and it looks like that just stayed the same. So in other words, it looks like we have x right here. We started with x, and then in the new point it's still x. Now, that leaves these two as corresponding parts. But they are not the same, so 2 became -2. In other words, the y value became the opposite of y. So this must be the rule. xy became x opposite of y. Okay, so now we can look back at our notes. X opposite of y, that is the rule for a reflection over the x-axis. All right, so this is a reflection across the x-axis. Now, that makes it easy. I mean, I could simply plot these points, A prime, B prime, C prime, but it's actually easier just to use your common sense. Here's the x-axis going horizontally. A is 2 above the line, so A prime will be 2 below the line. C is 3 above the line, so if I go 3 below the line, that will be C prime. And B is 5 above the line, so if I go 5 below the line, then that will be B prime. So A prime, B prime, C prime. So that'll do it for problem number 4.